This video we're going to discuss expected value. So what is expected value? Expected value is just an average. It looks at all the outcomes of an experiment and uses the probability of each outcome to come up with a value we can expect on average for conducting an experiment. To find the expected value, which we use the letter E to represent expected value, we're going to take each individual probability and multiply it by the outcome. So here the X's represent the outcome and the P's represent the probability of the outcome. So for each outcome, I multiply by its probability. Depending on how many I have is how many things I need to add together. So let's take this example of a spinner. In the spinner, I can see I have outcomes 1, 2, 3, 4 that all have the same probability of 1/4 of occurring. To find the expected value of this spinner, I would take each of the outcomes, 1, 2, 3, and 4, and multiply them by 1/4. When I add that up, 1/4, 2/4, 3/4, plus 4/4, I would get 10/4, which is 2.5. Again, this would give me the average. If I sat and spun the spinner a large number of times, my expected value, or my average that I would get, would be 2.5. So let's try to apply this to some scenarios that would help us make sense of this new idea. So here I have a restaurant, and I said this restaurant's on the beach. So it'll have 850 customers a day if there's no rain, and 125 customers on a day it does rain. If the probability of rain is 35%, what's the expected number of customers at the restaurant? All right. So I have two outcomes. I have rain and I have not rain, and I have the probabilities of each, which is 35% for rain, which means the probability of not rain would be 65%. So I look at, if it doesn't rain, I have 850 people come. If it does rain, I have 125. So you can see that I put the 35%, there's my raining with how many people, and then over here 1 minus 0.35, there's the other scenario, which is 0.65. So putting these two together tells me I would have 596.25 customers on average. Okay. Let's take this over to sports and say, what if I had a hockey team and I knew the number of points that the hockey team scored and the probabilities? So I have points from 0 all the way up to 5 and then the probabilities of each score. If I want to know the average number of points that this team scores, I can't just look at the chart and decide. I really need to put all those numbers together, and that's what expected value does for us. So you can see over here that I have this equation where I took each of the outcomes, 0, 1, 2, 3, 4, and 5, and I multiplied it by the corresponding probability I could find in the table. After I did the multiplication and the addition of all the outcomes, I got 2.68, so that tells me on average how many points I expect this team to score. The next one says, well, why don't we consider a raffle? So in this particular one, I decided we'd have 100 tickets and one prize of $50. We want to find the expected value of buying one ticket. Okay. So when we buy a ticket, there are two things that can happen. We can win the prize or we could lose the prize. Our chances of winning are pretty small, it's 1 in 100, but our chances of losing are really high. It's 99 out of 100. If we were to win, we win $49. You have to remember when you're doing expected value to include any of the costs you had associated with the experiment. If you lose, you just lost $1, so it's not high stakes. To get the expected value, I will take the two scenarios, so winning, which results in $49, times the probability, 1/100, and then the losing of -1 and the probability of 99/100. I can add the 49 to the -99. It gives me -50/100, which is -0.5. Okay. Notice on the raffle example, if we buy all 100 tickets, we would spend $100. We would be guaranteed to win the $50 since we bought all of the tickets. But overall, we will have lost $50. If we look at the expected value we found of -0.5 per ticket and multiply it by the 100 we bought, we would get -50, our total loss. Fair value is the price each ticket should cost for the expected value to be 0. For our example, we paid $1, but the expected value is negative $0.5. The fair price would be 1 plus negative 0.5, which is 0.50. Let's consider life insurance. A company will offer $50,000 life insurance for a 20-year-old for $150 per year. If the probability that the 20-year-old will die is 0.0001, find the expected value of the policy. So I do life insurance, not to be weird, but just because it's the easiest one to talk about because there's only two choices. With car insurance, you could have a minor wreck and have a little damage. With a house, you could have little damages. But with life insurance, there's only two choices. Either the person lives to the next year or the person has passed away. So if the policyholder dies, the company pays out $50,000, but it keeps the $150,000 paid for the policy. If the policyholder doesn't die, then the insurance company gets to keep the $150 for the policy. Notice in this case, I'm looking at this in terms of the insurance company. So when I look at the $50,000, it's negative because it would be paid out, and the $150,000 is positive because they received the money. They multiply that by 0.0001. That's a probability that they'll have to make this kind of payment. Then the opposite, if they just get to keep the $150,000, is very likely to occur. So here to get this 0.999, I did 1 minus 0.0001. Multiplying these two things together, and if you put this in your calculator, which I very much encourage you to do, make sure you use parentheses just like I did. You want this negative 50,000 and the 150. The parentheses around there will tell the calculator to first do this to do an order of operations before it multiplies by the 0.0001. Okay, this says on average the insurance company expects to earn $144 and 0.865 for each customer it takes. This says the insurance company expects to make money. They would not be interested in doing a fair value, and I would say most games don't look for that anyway. Fair value is not something that companies are interested in because that way they wouldn't make any money. So I think casinos don't care about a fair price. They want your money. They want to make it. Life insurance companies want to make sure they're making money. So fair price is something we talk about, but it's not something that I think happens very often in the real world. So let's do a U-try, and I have a couple. The first one is just going to be the chart gives the results of a survey about the number of times a person goes out to eat during a week. I want you to use the information to find the expected number of times someone from the survey goes out to eat in a week. And I gave the numbers as going from 0 times a week out to eat up to 5 times, and then each associated probability. So I definitely want you to stop the video, try this, use your calculator, and see how you're doing. So here is the answer. I took each of the outcomes in the chart and multiplied it by the number of times they went out to eat in a week. And I multiplied it together, and it says on average this group of people is going out to eat 2.26 times every week. All right, so let's try again. Say you had a multiple choice test, and that should feel kind of familiar. And there are 5 choices for each of the questions. You are awarded 3 points for a correct answer, and you lose a point if you have a wrong answer or you leave something blank, so if it's unanswered. So I want to know, what is the expected number of points when a student guesses an answer? So I want to know, did you gain points? Did you lose points? How did you do if you're just guessing? So try this one and then come back and check out the answer. All right. So hopefully, again, you were thinking that scenario of, well, what are my choices? I get it right, I get it wrong. So if I get it right, if I have no idea what's going on, I have a 1 in 5 chance of getting it correct. So I said only a 1/5 chance of getting it right and getting those 3 points. But if I guess, if I leave it blank, I had a 4 out of 5 chance of that happening, and then I would lose 1 point. So I have that 1/5 times 3, which is 3 over 5, and I have 4 over 5 times -1. I add that together, I get -1 over 5, which is just guessing, and the big picture is going to lose me points on the test. Okay, so here's one more you try, and this one's an investment scenario. to say an experienced investor believes he has a 33% chance of making $400,000 on an investment in a new startup. He believes his chance of breaking even on the investment is $42,000, and he has a 25% chance of losing $120,000. I want to know, what's the expectation of this investment? All right, so go through your scenarios, think about all the things that can happen, and then try to come up with how much you think this investor is going to make or lose on this investment. Okay. So here we are with the answer. So I have the outcomes of gaining $400,000 times 0.33, breaking even, which means 0, right? There's no net there, so it's 0.42. And then this plus a negative, so it's a negative $120,000 of 0.25. Right? Putting that all together says his expected return on this investment would be $131,970.